there's a school in which class 8th has 12 boys and 8 girls. So total strength of the class is 12 boys plus 8 girls. That is 12 plus 8, which is 20. So total number of students in class 8th is 20, out of which 12 are boys and 8 girls. So we've already seen how to compare these boys and girls in a class by ratio. What I can say is that ratio of boys to ratio of girls in class 8th is 12:8. This is what we've already seen. Now we can express this ratio by division. So I can say that 12:8 can be expressed as division, that is 12 divided by 8. Now when we have division, we can divide the numerator and denominator by the same number. That does not change the fraction here. So this can be expressed as division, which is 12 divided by 8. Further, you can divide both the numerator and denominator by the same number. That would not affect the fraction. So let's say I divide both the numerator and denominator by 4. What do I get? 12 divided by 4 gives me 3. 8 divided by 4 gives me 2. So this is what I get, 3 by 2. Now 12 by 8 is nothing but 12:8 if I write it in ratio. And this comes out to be 3:2 if I express this fraction or division as ratio. And further, what we see is these two are equal. So what we get is that just like fractions, in a ratio, you can divide the antecedent and consequent by the same number, which is 4, and you get this. So the ratio does not change. It's the same ratio. Or you can say that you can multiply both the antecedent and the consequent by 4. 3 into 4, 12. 2 into 4, 8. So if I multiply both the same numbers, I get this. If I divide both these numbers by a same number, I get back to this, which are equal. So the ratios are equal if you divide both the antecedent and consequent by the same number, or if you multiply both the antecedent and consequent by the same number. A ratio usually is expressed in its simplest form. That is, you have to make sure that there are no common factors in the antecedent and the consequent. So here 12 and 8 had a common factor 4. So I divided it by 4 and I get 3:2. Now this does not have any common factor, so I can leave the ratio as this. Now let us see what the ratio tells us. We have 12:8 here. That is 12 boys to 8 girls. That is ratio of boys to girls. So that is 12 plus 8, which is 20. Out of 20, I have 12 boys and 8 girls. Now I've seen that this 12:8 is also equal to 3:2. Now what does this 3:2 mean? How can I read this? Now 3 plus 2 is 5. That means in 5 students, I would have 3 boys and 2 girls. Now what about the rest of the class? Now that means 3 plus 2 is 5. What 5 indicates is that I can divide my total class into groups of 5 in such a way that each group of 5 students would have 3 boys and 2 girls. So I can divide the entire class into such groups. So I get groups of 5 students, and in each group what I'll see is 3 boys, 2 girls. 3 boys, 2 girls. So number of boys again you can see would be the same, which is 3 added 4 times, 1, 2, 3, 4. So 3 boys added 4 times, which is 12, total number of boys. And you can see here 2 girls added 4 times, 1, 2, 3, 4. 2 added 4 times, 2 times 4, which is 8. That is 8 number of girls. So usually what we do is we express the ratio in the lowest form. Now let's look at this. How do we come back? So if you're given ratio in the lowest term, how do you actually find the number of boys and number of girls in a class? Let's say there are 20 students, what we've just seen, and we've seen that the ratio of boys to ratio of girls in class 8 is 3:2. Now how do I actually find the number of boys or number of girls in the class? what you can observe is that what we had seen is that the number of boys or girls are nothing but a multiple of this ratio only. So let us assume that ratio or the number of boys in the class is 3 times x. Let us assume that number of boys is a variable x. So what I do is I multiply the antecedent and consequent both by a number which is x. Same number, does not change my ratio. So I get 3x and 2x. Now this represents the number of boys in the class and the number of girls in the class. So what I get is that the number of boys in the class would be 3 times x, that is 3x, and the number of girls in the class is 2 times x, which is 2x. Remember that the number would be a multiple of this ratio only. This is the ratio in its lowest form. Simplest form, what you need to do is multiply by a number which we assume here in this case, which we suppose as x. So a multiple of that would be 3x and 2x. Number of boys and number of girls in the class. So now I can find the total students. Total students would be nothing but number of boys plus number of girls, which is 3x plus 2x. So I get total students as 3x plus 2x, which is 5x now. So total students is 5x, but I already know that total students are 20 here. So what I can say is that 5x, which is the total number of students, is equal to 20, because total number of students are 20. So from here I can find that x is 20 divided by 5, which is 4. So I can find x from here. I knew 5x is 20, x is 4. Now number of boys in the class is 3x, which is 3 times x. So 3x, which is 3 times x, and x is 4. So 3 times 4, which is 12, which is true. We've already seen that number of boys were 12. So which is 3x, 3 times 4, 12. Number of girls in the class are 2x. And I already know x. So number of girls is 2x, which is 2 times 4, because x is 4, which gives me 8. So this is how I found number of boys and number of girls. Now another way to look at it is, we know total students are 20, and the ratio we know in the simplest form is 3:2. Now this means if I find the sum of the terms, then it is 3 plus 2, which is 5. So first find the sum of the terms of the ratio, which is 3 and 2. So 3 plus 2 is 5. Now this means that 3 students out of 5 are boys and 2 out of 5 are girls. That is 3/5 of the total students are boys and 2/5 of the total students are girls. So number of boys would be, number of boys in the class would be 3 by 5 of total students. This is boys to girls. So boys to girls. Now number of boys would be 3 by total, which is 5, sum of the terms. So 3/5 of the total students. Now this would be total students in the class, we already know are 20. So this is 3 times 4, which is 12. So I can find the number of boys in the class, which comes out to be 12. Similarly, I can find the number of girls also, which would be 2 by 5 of the total. So number of girls would be 2 by 5 into total students, which is nothing but 2 by 5 into 20, which is 2 times 4, which is equal to 8. So number of girls comes out to be 8. So this is how I can find from the ratio total number of boys in the class, which is 12, and total number of girls, which is 8. Now rather than finding the total number of girls, you could have solved it from here only. We found the number of boys in the class is 12. We know the total number of students also. So we can find the number of girls. We know number of boys is 12. We know total students are 20. So girls would be the remaining students. So girls would be total students minus the number of boys. If I subtract the number of boys from the total class, I would get number of girls. Total students were 20. If I subtract number of boys from it, which is 12, so 20 minus 12 gives me 8, which is the number of girls. This is how you can find number of girls in the class, which is 8. So we've seen that 12 is to 8 is equal to 3 is to 2. That is, if you divide the antecedent and the consequent by the same number, the ratio does not change. Or similarly, what I can say is, if you multiply both the antecedent and consequent by the same number, the ratio remains the same. But remember that 3 is to 2 is now not equal to 2 is to 3. That is, you cannot switch the two. The order changes. The order matters. So the ratio changes when you change the order. Here 3 is to 2 is ratio of boys to girls. Now, if you keep the quantity the same, that is ratio of boys to girls, and here also you have ratio of boys to girls, and you just switch the numbers, which is from 3 is to 2, you make it 2 is to 3, then it is not the same, because this says that in 5 students, that is 3 plus 2, 5, you would have 3 boys and 2 girls. 3 boys and 2 girls. Whereas what does this mean? This means that in 2 plus 3, that is 5 again, in 5 students you would have 2 boys and 3 girls. 2 boys and 3 girls. So it is not the same. Do not inverse the numbers. That does not remain the same. So remember that. That is, order is important while writing the ratio. Just see what are you trying to express and then correctly write the order. Ramesh and Vinod, both of them, go to a pizza corner to buy a pizza. Now the pizza costs 250 rupees. So Ramesh gives 100 rupees, whereas Vinod contributes 150 rupees. So both of them, now the pizza had 10 slices. So the pizza was served in 10 slices. What they decide is that both of them will have the pizza in the ratio in which they have contributed the money. That is, they say that they would have the pizza in the ratio of money they have contributed for the pizza. So now, can you tell me how many slices would Vinod get? Let us see. We know that the money contributed by Ramesh to the money contributed by Vinod is 100 is to 150. Now if I want to express this in the simplest form, I have to find all the common factors and divide by them. So I see 10 as a common factor. So this would give me 10 is to 15. Further, I can divide both by 5, which gives me 2 is to 3. This is what I get. That is, the ratio of money contributed by Ramesh to Vinod is 2 is to 3. This is what I know. I also know that the pizza has 10 slices. Now I want to find the share of Vinod. How many slices would Vinod get? This is what I need to find. So we know that pizza has 10 slices. We know Ramesh to Vinod, the ratio is 2 is to 3. That is, the money which they contributed is in the ratio 2 is to 3. And they would have the pizza in the same ratio, which is 2 is to 3. So how many slices would Vinod get? So the sum of the terms of the ratio is equal to 2 plus 3, which is 5. I can find the sum of the terms, which is 5, 2 plus 3. Now I want to find Vinod's share. So Vinod's share would be 2 is to 3. So 3 out of 5. That is 3 by 5 of total slices. This would be the share of Vinod, which is 3 by 5 of the total slices in the pizza. Now this is 3 by 5. We know that the pizza was divided into 10 slices. This gives us 3 times 2, which is equal to 6. That is 6. So Vinod would get 6 slices of the 10 from the pizza. So slices that Vinod get would be 6. So Vinod gets 6 of the 10 slices to eat in the pizza. So this is how you can use ratio to find share of Vinod. Now let's look at this. We have Ramesh, Vinod, and joined by a friend, Gopal. Now 3 of them were discussing the mathematics test. Ramesh got 60, Vinod got 40, whereas Gopal got 50. Now I can use ratio to compare the marks of any 2 of these students. So what I can do is, I can compare the marks of Ramesh and Vinod. That is, ratio of scores of Ramesh to Vinod is 60:40. I can also compare the ratio of scores of Ramesh and Gopal. So ratio of scores of Ramesh and Gopal would be 60:50. That is 60:50. Similarly, I can compare the scores of Vinod and Gopal also, which is 40:50. 40:50. So far we have used ratio to compare quantities of the same kind. That is 2 quantities of the same kind. That is scores of Ramesh Vinod or scores of Ramesh Gopal or scores of Vinod and Gopal. Now we'll see how we can use ratio to compare all 3. We can use ratio to compare these 3 quantities also. That is the scores of all 3. I can simply write it as 60:40:50. That is the score of Ramesh to Vinod to Gopal. So ratio can be used to compare 3 quantities also. So I get that ratio of scores of Ramesh to Vinod to Gopal is 60:40:50, which is 60:40:50. So this is what I get. Ratio of scores 60:40:50. Now from this I can read the ratio of scores of any 2. This is Ramesh's, this is Vinod's, and this is Gopal's. So now from this I can find the ratio of Ramesh to Vinod, which is 60:40. I can find the ratio of scores of Vinod and Gopal, which is 40:50. I can also find the ratio of scores of Ramesh and Gopal, which is 60:50. So from this 3, I can read any 2. I can compare any 2 also. So this is what I get. Now further what we had seen is that a ratio has to be expressed in the simplest form. What you can see is that there is a common factor 10 in all these 3 terms. So I can divide all the terms by 10 and I get 6:4:5. Now these 2 terms have a common factor 2, but 5 does not have 2 as a factor. Now I cannot express it further in the simplest form because all 3 terms do not have the same common factor. So we do not have one common factor which divides all these 3 terms. So no common factor in these 3 terms. So this is the simplest form. So we can say that ratio of scores of Ramesh to Vinod to Gopal is 6:4:5. So now what happens is, we know that the ratio of the scores is this. Now the teacher has 60 chocolates with him and he decides to distribute these chocolates in the ratio of the marks scored by these 3. So he has to distribute those 60 chocolates among these 3 students and he decides to distribute those chocolates in the ratio of the scores they have obtained. So we know that the ratio of scores is 6:4:5 and the total number of chocolates that have to be distributed is 60. So now can you find how many chocolates would Ramesh get or Vinod get or Gopal get? I want to find the share of chocolates each person gets. So I know the total number of chocolates is 60. I know the ratio also in which the chocolates would be distributed. So sum of these terms would be 6 plus 4 plus 5, which is 15. So sum of the terms of the ratio is 6 plus 4 plus 5, that is 15. Now let's find each one's share. So Ramesh's share would be 6 out of these 15. Sum of terms is 15. So 6 of 15 of total chocolates. which is equal to total number of chocolates is 60. 15 fours are 60, which gives me 6 times 4, which is 24. So number of chocolates that Ramesh gets is 24. Now let's find Vinod's share. This is Ramesh's share, 24. Now let's find Vinod's share, which is 4 of these 15. That is 4 by 15 of total chocolates. Which is equal to 4 by 15 into total chocolates to be distributed as 60. This gives me 16. That is, number of chocolates that Vinod gets would be 16. Now let's find Gopal's share. One way is to do is, we know total chocolates that are to be distributed is 60. We know share of Ramesh, which is 24. We know share of Vinod, which is 16. So 24 plus 16, and you can subtract this from the total number of chocolates to get Gopal's share. Or else we can follow the similar way. We can find Gopal's share, because we know it is 5 of the 15. That is 5 of 15 of the total chocolates. Now total chocolates we know are 60. So this gives me 20. That means Gopal would get 20 chocolates out of the 60. So we know that the ratio of marks which they obtained was 6:4:5. That is, ratio of scores of Ramesh to Vinod is to Gopal is 6:4:5. And the share of chocolates also we know. Ramesh gets 24, Vinod gets 16, and Gopal gets 20. Now you can see this, you can add these three, and you would get 24 plus 16 plus 20 gives me 60. So we've seen it's correct. 60 chocolates were to be distributed, and this is the share of each. So this is how you can use ratio, not just to compare two quantities, but you can use ratios to compare three quantities also. And similarly, you can find the share of each person also.